Thank you very much. Thanks for having me. So I'm not going to do any live coding, but I'm going to do live executing, a fair amount of it. So when it works, it's actually pretty cool. When it doesn't, it's pretty uncomfortable. So I think either way, it'll be entertaining for you. So my name is Mark Head, and I work for a company called Voxeo, and we have some telephony platforms that people like to use. So I'm mhead on Twitter. I'm just plain mhead on everything else, including GitHub. I've been a telephone and voice application developer for about 10 years. I've built voice applications on just about everything you can build a voice application on. There are a whole host of alphabet standards there that I put there. I will talk about each of them in probably painstaking detail. I've built voice over IP enabled phone applications using Asterisk and many other platforms. And I currently work as a developer evangelist at Voxeo Labs. So, who cares about phones? Why do we care? It's not a rhetorical question. Why do we care about telephony? Yes, throw it out there. Yeah, phones feel real, and it turns out that almost everyone has them. The telephone penetration rate in this country is around 95%. There have been a host of studies done about people's preferences for contacting businesses and governments, and consistently telephones rank at the top in terms of their choice for communicating. So we care about phones because there are lots of them. It's the most ubiquitous communications device on the planet, and everyone knows how to use one, pretty much. So I've made I would submit to you that the future of telephone application development is JavaScript, and Node.js actually plays a pretty important part, I believe. So that's my contention. Before we can challenge that contention, and I would encourage you all to do that if you don't believe me, we need to understand how we got here and how our telephone applications built currently. So there's a famous quote at the top, we will discover the future by understanding the past. It's actually not a famous quote, it's me. I made it look famous by enclosing it in quotes. Let me give you a brief history of telephone and voice application development. So in the late 90s, telephone application development usually meant low-level programming against proprietary API. If you wanted to initiate phone calls or take phone calls, you had a server with a telephony card in it with either analog phone lines plugged in or a channelized T1. And you were writing low-level code against an API that was for that specific telephony card. So in the mid to late 90s, the big telcos got together under the auspices of the W3C. Each of them had some flavor of a markup language for telephony in the works. And the W3C brought them all together, and there was a very great effort to standardize markup languages for telephony. So the idea was, let's make telephony development like web development. Lots of languages, all languages, can render markup for consumption by a browser. So that was the idea. So the main standards are VoiceXML. Anybody ever heard of VoiceXML? All right, cool. Anybody ever built a VoiceXML app? All right. So VoiceXML is a standard for dialogues, the interaction between a person and an application. CCXML is for call control, and the speech recognition grammar specification are the rules for speech recognition. This is just a quick example of a VoiceXML application. Very simple. You'll notice a lot of JavaScript in here. I wanted to make the point that along with these standard markup languages, the W3C and the working group that created these languages saw fit to include JavaScript support. So really all this does is you call it, it says hello and welcome to VoiceXML. It says the alphabet, and then it hangs up. But you can see I can split arrays, I can use data objects, I can throw and catch events. This disconnect element here will actually throw a connection disconnect event. So pretty cool stuff, pretty cool stuff. JavaScript lives here. So JavaScript was incorporated into these standard telephony languages. And again, the idea was to make telephony development like web development. The large telcos very wisely realized that in the late 90s to early 2000s, the number of web developers was increasing rapidly, so they wanted to capitalize on that and make telephony development just like web development. There are no AJAX calls, but there are ways you can actually get external data into VoiceXML and CCXML applications. This data element in VoiceXML gives you a read-only subset of the DOM, so you can traverse over an XML document. In CCXML, some platforms actually support ECMAScript for XML, which is kind of cool. Another way to get data into an executing voice application. Since that time, there's been a lot of changes. A lot of changes. We live in a time now where it's never really been easier. It's never been easier to build a telephony application. And when I say telephony application, from now until the end of my talk, I mean it in its broadest sense. I mean DTMF tones are the noises your phone makes when you press buttons on it. Speech application, text messaging application, basically anything you can do with a standard regular phone or mobile phone. There's been a lot of change, lots of options now. And many of those options are not standards-based. They are not these standards-based languages that were developed with great effort by the W3C and the large telcos. Why is that? Well, there's a number of reasons. I would point chiefly to the observation that a lot of people don't like to program in XML. VoiceXML and CCXML have a very steep learning curve. You get an incredible amount of control over a telephone call. CCXML especially, you get a very granular level of control with a phone call. The problem is, the trade-off for that is complexity. It's very complex. I'm going to show you a JavaScript application that will transfer a phone call in one line of code. I've actually written transfer logic for production voice applications that were 65 lines of code, doing everything from connecting a caller, playing a ringtone to them, bridging call legs. So these languages have the benefit of being standard and portable. There are over 50 implementations of these standard telephony markup languages. So portability is a big selling point for them. The problem is they're very complex. They're very hard to use. They have a steep learning curve. So something else has changed, too, that's driving how telephony apps are built. Voice over IP. All telephone calls at some part of their life cycle, and this has been true for actually a while, spend time on an IP network. Retail consumption of VoIP services is large and growing. You've probably all heard the statistic about Skype being the largest telephone company in the world. It's true. Almost all business class telephony systems are now VoIP enabled. And when I say VoIP in that sense, I mean SIP, the SIP standard. The lines between the different modalities is blurring or moving towards what the consultants call unified communications, where conversations will happen across modalities, a phone call, instant message, email, all these sorts of things are converging. So to meet the needs that we have now, the development languages we use to build communication applications, they have to be powerful, they have to be flexible, and they have to be channel agnostic. They cannot be tied to a specific channel. So I don't want to bore anybody. Anybody here know about SIP, the SIP standard? We feel comfortable with that? Let me just hit it real quick. So SIP is the Session Initiation Protocol. It's a signaling standard for VoIP telephony. So a SIP exchange of SIP requests and responses is meant to set up a telephone call. So SIP endpoints will have a conversation and say, what voice decoder do you want to use? What channels, or excuse me, what ports are we going to exchange media on? All these sorts of things that are negotiated before a phone call. And then when that negotiation is complete, the call starts, the conversation happens. SIP is used in concert with other VoIP protocols like real-time protocol, which is the actual protocol for streaming media. It's very similar to HTTP in the sense that it has a pretty simple to understand request and response paradigm. And very importantly, SIP headers, you can set them just like HTTP headers. So you can actually drape information on a telephone call essentially and pass it along a telephone network. Pretty powerful idea. And really something that you need to have for next generation telephony. So if your VoIP, or excuse me, if your telephone provider isn't SIP interoperable, then I don't think they're going to be around for very long. So building communication apps with JavaScript. As I said before, there are more choices. I'm going to go over several of them. There are a host of different platforms out there that you can use. Like I said, it's a target-rich environment. It's never been easier to build a telephone application. There are very compelling options, I believe, for JavaScript developers. we're going to talk about 3 different kinds of telephone app development. I'm actually going to walk you through a few of them. A telephony app execution environment like Tropo, which is the platform that we provide, where your JavaScript code is actually executed in our environment. There's another company that does that as well. They were called Soft IVR. They were a UK company. We're going to build a telephone inside of a web browser using a jQuery extension called Phono. And we're going to use Node.js to do some really cool stuff. Node.js in particular, my contention is that it has some properties that make it especially attractive for next generation telephony. And I believe that we will see Node.js used more and more with telephony applications. Okay, so what does JavaScript look like in Tropo? So this is the functional equivalent of the alphabet example that I showed you a minute ago. So this is pretty straightforward, pretty easy to understand JavaScript. I'm going to start flipping around now. I hope that doesn't annoy everybody. I'm going to try and at least show you a few things. I'm going to give away all my stuff, though. So what I want to do is actually, call this and see if we can get this to work. I have no idea what this will sound like.
Hello and welcome to Tropo. A, B, C, D, E, F, G, H, I, J, K, L,
Get the point.
N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now I know my ABCs. Goodbye.
Okay, so there's actually another standard for formatting or styling text for text-to-speech engine. I didn't want to overcomplicate this, though, so I just sort of used the phonetic. Text-to-speech engines sometimes need a little bit of help, so I wanted to give it that. So that's a basic JavaScript application in Tropo. You can you can host this remotely and deliver to Tropo unexecuted. You can host it with us, and we'll execute it for you. So here's a very simple Node.js example. This is not the Node.js stuff I'm going to show you in a minute, which is actually really, really cool. But we also have another API where if you want to, if you need to integrate with external systems, we have a Node module. This is the ubiquitous Hello World web server example for Node with a little bit of Tropo flavor. This is really nice because if you want to use any one of the growing number of Git-based deployment options for your Node app, you can do that. It's pretty nice. So everything's sort of out in the cloud. Okay, so now I want to talk about building browsers, building telephones in your web browser. And I'm going to use a jQuery plugin called Phono. If I can find it here. There it is. So Phono is jQuery. I gave this away a little bit, but I actually have a Phono instance loaded in this browser. Let's just reload it. And what we'll do here is we'll just check out the source. Can you all see that? So this should look pretty, so I'm referencing some external JavaScript here, but this should all look pretty standard, right? I've got a Phono object here. You'll see I'm actually dialing something, an app : number. I'll explain that in just 1 second. And you can see I've got on ring, on answer, on hang up. I can handle an incoming call. So I'm going to do all that right now. One of the things I want to show you first is, let's do this. So I actually wrote out to the console the Phono identifier. So this is a unique identifier that each Phono instance has every time it's loaded in your web browser. And if it looks suspiciously like a SIP address, that's because it is a SIP address, which means not only can I make telephone calls from this Phono instance, but I can receive telephone calls at this instance, the phone will ring in my web browser. So let me see. So I explained a second ago about this, this app : and this identifier. I can actually put a regular 10-digit telephone number in here, and it will call it. Right now, we limit calls to real telephones to 10 minutes, and there's a little speech you get before the phone connects that says, hey, thanks for trying Phono. You get 10 minutes of calling time with this. If you want to do something else, create an app on Tropo. So what I did was I created a very simple application on Tropo. It looks like this. So this is the one-line transfer I was telling you about. So what this will do is this will transfer the call. So Phono is going to call this app. Tropo is going to call me on my cell phone. It's going to answer on media, which means we'll hear the ring right away, even though it won't connect. I'll give it a 60-second timeout. And I'm actually going to set the caller ID to my home telephone number, so it will look like my wife is calling me to find out what's going on, asking me how my demo is going. So, see if it'll work. Hello?
Hello?
Can you hear me?
Can you hear me?
Say goodbye.
Say goodbye.
Now, it gets cooler. It gets cooler. So I probably shouldn't have closed that console. I needed that. What's that? Make what bigger? Sorry. You all see that? All right, so let me do this. I have a SIP phone here. I have there's my call. Now, I don't have any logic in here to actually do anything with the call. I just kind of wanted to prove the point that this is a unique instance that I can, whoops, settle down, that I can actually call. Now, I wasn't going to do this, but I feel like oh, come on now. Settle. So I wasn't going to do this, but I wanted to because the Zappo guys, something's ringing. The Zappo guys mentioned they're hiring for their call center. So call centers are really interesting because they have there's a lot of overhead to a call center. There's people, you have to staff it. There's a lot of equipment. There's a lot of telephone switching equipment. There's automatic call distributors. There's DNS-based routing. You've got to know what agents are on, when they're on, so you can route calls to them. So call centers tend to be really, really so equipment intensive. There's lots of equipment. So I've got this project that I've been working on, and if you go to my GitHub profile and you see remote agent, this is a couch app that's built with Phono. So the way it works is when you go to the couch app and you open up the index page, what you should get is a phone. And the neat thing about it being a couch app, you remember I mentioned the unique identifier. Since they are unique, I can then store them in CouchDB, and I can make the SIP address, which is unique, my document ID. What it also means then is that now that I know that I've got an agent who is, let's see here, who is ready to take a phone call. So by doing a simple HTTP query of CouchDB instance, I can get agents who are ready to take a phone call. These agents can be anywhere. It doesn't matter where they are because we're doing SIP telephony, right? And I know when they're ready to take a phone call, and I don't need to work with them to install a SIP phone in their home and worry about all sorts of crazy networking issues and user issues with people trying to figure out how the phone works, because all they've got to do is open a web browser. So let's call this thing. It's got something of a unique ringtone, a non-call center ringtone. But we'll give it a try. Let's make that go away. That's kind of annoying me. Can everybody see okay?
Agent 94, this is Command Base. Please answer your communicator. The future of the unit. All right.
So you get a lot of neat ringtones with Phono as well. So the interesting thing here is that I've been able to attach to this answer event essentially, and what I can do with that is I can update my CouchDB instance and say, this agent is not ready now. This agent's on the phone. So if calls are coming in and I'm querying my CouchDB instance to get agents who can take a phone call, I know that this agent is now occupied, so not to send a call to them. So just real quickly, if you go into this this solution, you'll see it runs with Asterisk. So Asterisk is anybody ever heard of Asterisk before? Okay, it's an open source telephony platform. Node.js is actually a really good complement to Asterisk. And one of the things I've gotten here is a Node script that actually is a TCP server that will accept connections from Asterisk, and then it will use an HTTP client to connect to CouchDB. And because you can build network applications so easily with Node, it's a really, really good fit for this solution. So if you go to my GitHub repo and you check out Remote Agent, I think you'll like it. It's a pretty cool project, and I'd love to hear any feedback. Zappos call center, man, right here. Okay, so what I didn't show you was the ability to send and receive instant messages with a Phono instance as well. You can do that in the web browser. The neat thing about that is if you want to route calls to an agent, you can give them a screen pop and say, we'll do a quick caller ID lookup and say, hey, it's Joe Smith calling. Here we can hit a CRM system and say, hey, Joe Smith ordered X, Y, and Z the last time he called, so the agent can answer and go, hello, Mr. Smith, I see you received your shoes or whatever we're buying today. Okay, so I mentioned just a second ago Node.js and the ability to build network applications. So phone calls are happening on networks, they're happening on IP networks. So the ability to build something that can speak and consume network-based protocols is really important for telephones. So this is still sort of new. There's actually a SIP module for Node. The author there isn't a lot of documentation on it, but he's very open to conversation and email about it. And I and one of my colleagues, Chris Matthew, who is down in the middle there, have actually had conversations with this guy. He's very helpful. What I wanted to do was I wanted to build a SIP registrar. So a SIP registrar is a component that keeps track of SIP clients. Because SIP clients can exist anywhere. Their IP addresses can change based on what network they're connecting to. So a SIP registrar, basically, a SIP phone will register and say, here I am, I'm at this location. So all somebody has to do to find that person and call them is simply call the registrar using the registrar's address. The registrar will tell that phone, oh, this person's over here, you need to redirect over here, or this person has now moved over here. So I wanted to build it with Node.js. I also wanted to build it with Redis, because these registrations really are sort of an extension number and a SIP address. So it's sort of a name-value pair. It seemed like a really easy fit for Redis. I certainly could have built it just using straight Node, just using an array or something and just storing up these things. But I wanted to sort of make it more real world. So what I'm going to do is I'm actually going to show you the SIP registrar that I built, and we'll see if we can get it to work. That won't work because I don't have my Redis server running. Okay. So what I'm going to do is, first I'm going to hang up the phone. I want to get this SIP client. This is a Blink SIP client. It's pretty nice. I got no complaints about it. But what I want to tell it to do is to register with this machine, the IP address that I've been given by this network, and I'm just going to use an extension of 200. So I told it to register, and it did, and it came back green. And there it is. There's my registration. The actual code for this, let's see. Okay, can everybody see this? Yes, no? No? You can't see that? Are you for real? So, all right, well, yeah. So this is probably a little bit too much to consume in this manner. Let me just kind of break it down for you like this. So there's this awesome Redis module for Node. I recommend it. It's really easy to use. And as I mentioned before, there's a SIP module that I'm using. So I want to handle basically two kinds of SIP messages. I want to handle a registration, a register. So when a SIP request comes in that is a register request, I want to populate the IP address, basically the SIP, fully qualified SIP address of where that phone is in Redis. And I also want to log them off if they close their phone down so that I don't have a record for them. The other thing I want to do is when I get a SIP invite, which is what a SIP client will do when it wants to connect to another client, it will send a SIP invitation. What I'll do is I'll send back an initial response with a 100 saying I'm trying. I'm going to look up this person and see if I can find them. Now, this is typically where you'll hear a ringtone. So your client has been told, okay, the other end is trying to find where to route your call. Please hold, and we'll play a nice ringtone for you. And when I find them, if I don't find them, I'll give them a 404 back. This should look and feel a lot like HTTP, right? If I do find them, I'll give them a SIP 302, which is a redirect. So all I'm doing here is saying, I'm going to look up the person that you're trying to contact, and then I'm going to tell your SIP client to go and find them where they've last registered. And then your two SIP clients will negotiate the entire call, you'll exchange media, you'll have this great conversation. It's all powered with, less than 85 lines of Node.js, and I'm probably being a little verbose here. We could get this down under 50 easy. So if what I just said to you was true, I do have a registration, so I should be able to open Redis and go get, what did I register him at, 200? Yeah, so there it is. There it is sitting in Redis. Now I should be able to call that SIP address at my local host because that's where this is running. And if I do that, oops. Actually, let's take that away. My phone should ring. My phone rings. I'm going to reject that because I'm going to get a weird echo if I answer the phone and I'm trying to talk as well. So that seems sort of anticlimactic compared to the last one, but trust me on that. That is pretty awesome to be able to write a SIP registrar with Node.js and using a database like Redis. There are some pretty sophisticated and complicated SIP registrars out there. And while mine does not do some of the things that they do, it's still pretty neat that you can roll your own SIP registrar with Node.js. So it sort of underscores my point, my contention that Node.js, I believe, going forward has a really important role to play in telephony because increasingly telephony is happening on IP networks. Okay. Oops. Get back to my... Okay. Here's the other thing that Node.js is really good at. It's really good at gluing disparate components together to make a really interesting application. So sticking with Redis for a minute, one of the really neat things about Redis is that, and it has nothing to do with Redis being a data store, is that Redis can act as a publish-subscribe framework, basically. So clients can connect to a Redis instance and they can publish on a channel. And other clients can subscribe to a channel and listen for messages on that channel. And everybody that's everybody that's subscribed to a channel gets the message when a publisher publishes to that channel. So I wanted to use a Tropo app, and I wanted to use speech recognition, and I wanted to have Redis instance out in the cloud, so I ended up going with Redis to go, which they have a bunch of nice plans, and it's very easy to use. So the Tropo app, just to sort of, I guess, make the point that Chris made it, I think, the first day or early yesterday. He said, this is, even though we're here to talk about JavaScript, there's a role to play in lots of other languages. So as a nod to that notion, I've coded this in PHP. It's a PHP application. I'm going to show you the code in just a second. And what it's going to do, it's going to publish information on a channel that's in Redis, a Redis instance running in the cloud. So I want to be able to do something with this information in a web page. And so I'm using Node.js as sort of a proxy subscriber for a web page. I'm going to use, again, the Node Redis module, which is really awesome, and Socket.io, which is equally awesome. And just use some simple jQuery in a web page. So, oops. There's a lot in this, but this is the meat of it right here. I'm going to connect to a Redis instance. I'm going to authenticate. I'm going to say, welcome to the Redis, hello. That actually makes it sound better. Then I'm going to prompt the user. I'm just going to say, tell me the color you want to see. Tell me the color you want to see. And every time I do that, I'm going to publish on this tropo.color channel. And when they say stop, I'll disconnect, say goodbye, and hang up. That's pretty much it. As I mentioned before, Redis to go. I'm using this free plan down here, which is very inconspicuously advertised. So let me see if I can run this. Yeah, so first let me show you the node. Shit, sorry. Let's do this. It's a really simple node script, just using the Redis module and socket.io. Let me also show you. Shit, that's not going to work because I'm not running my server yet. Let's do this. So this is all on GitHub, and I'm going to probably beg your indulgence and point you to the GitHub repo where it will be easier for you to understand this. But it's a very simple Node script. It's going to subscribe to a Redis channel. It's going to get information from that channel, and it's going to push it to a web page that's through socket.io. Let's do this. Okay, so I'm now connected, and my Redis client is subscribed to the Tropo color channel. Now we can look at the. So this is really easy. I'm not really doing much here. I'm getting some information, and I'm modifying some CSS. That's pretty much all I'm doing. But it actually turns out that that's really kind of cool. So this is my Tropo application. When you set up a Tropo application, you get a lot of stuff for free. You get a Skype address and a SIP address that you can use. So I've given this demo a few times. I actually gave it a month ago in San Francisco. So I've got a San Francisco number. And I've also got a Portland number that I've provisioned. So I guess with all that lead up, this should really be, this better be something good, right? Is what you're saying. Bear with me for just a second here. Okay.
Welcome to the Redis and socket.io test. Say the color you want to see. When done, say stop.
Blue.
Say the color you want
Quite.
to see. When done, say stop.
Blue.
Say the color you want to see. When done, say stop.
Yellow. Okay, I'm going to hang that up. Now, the other neat thing about Tropo is that I mentioned before that the tools that we use need to be channel agnostic, right? So we need to be able to use one code base, and we need to be able to serve multiple channels. Well, Tropo does that really well. So what I've done is I've gone ahead and I've added an instant messaging, just a simple Jabber account to this application. And what that will let me do is then interact with this thing via IM. Same code base. It's just serving on a different channel. The other neat thing I can do, why don't we do this? Since you've all sat here very patiently and listened to me blather on about all this, why don't we do this? If you send a text message to that number, your choices should be red, green, blue, white, and yellow, I think. We should see, everybody got it? It's 503-847-9316. Oops, somewhere my, hold on. Hold please. Where did it go? Oh, there it is, sorry. So if I send a text message to 503-847-9316, what I should get is a change in color. There we go. Somebody's texting. Keep going, come on. Send green, I sent green, so. So it just sort of illustrates the point that the tools we need to use going forward are going to need to be agnostic to channel. And this is one way of addressing that need. You guys are going to keep texting that, aren't you? All right. Okay. So before, I don't know if people have questions. I'm not even sure where I am on time. But I just kind of want to underscore a couple things. So the way that we develop telephone applications has changed dramatically recently. And it's because web development has changed. The way we build things has changed. And there's a desire for easier ways to do things. So for JavaScript developers, that means we've got lots of choices now in how we build powerful multi-channel communication applications. I believe very strongly that going forward, Node.js will play a very important part in telephony and in how we build and deploy telephony applications because of the things it does. It's very easy to build network applications with Node. We all know that. That is a perfect fit for telephone applications because telephone calls happen on networks. The other thing is telephone environments are they're event rich. They're full of events, connections, disconnections, transfers, the whole life cycle of call progress analysis in terms of figuring out whether you're talking to a human or a machine. Very event rich, and Node's event model is a really, really good fit for that, I believe. I don't know of anybody that's doing CPA, call progress analysis with Node. I wouldn't be surprised. I didn't know there was anybody doing a SIP module until I went out and looked. So it's all good. We have lots of choices, and there are lots of cool stuff to build. Thank you very much.
Laura, did you remember to load the bacon?
Oh, I knew I forgot something.